everybody. So let's talk about abstract classes, but before we do, I think they're going to make most sense in comparison with the things that we've looked at already, so interfaces and just regular inheritance. So here we are so far. We're making a payroll system, and we've got at least two different kinds of employees, salaried employees and hourly employees. So one way of capturing what we want these classes to do would be to create an employee interface that defines what does it mean to be an employee object. In particular, it will specify the methods that all employees must implement. And so then we can create our specific employee classes, and we can stipulate that each class must implement the employee interface. So that would look like this. For example, we have a public interface employee, and we have the methods, and because it's an interface, we don't supply the method bodies, we only have the method signatures, so that's why they all end in semicolons. And then we'd have an hourly employee, and we would say that it implements the employee class, but then we would have to add the unimplemented methods, and we would have to implement them all. And the same thing for our other class. Okay, so let's talk about what's good and bad about this for 25 seconds. So two things that are good about this. The first is that it's extendable. We've encapsulated what does it mean to be an employee, and so if we wanted to add other types of employee, we could easily do so by creating other classes that implement the employee interface. Another nice thing about this is it lets us use something that's like polymorphism. So we could have an array, or we could have a list of lots of different classes, lots of different objects that all implement the same employee interface. And then if we iterate over our list of different employee objects, we could run the calculate pay method on all of them, and we would feel safe that the right calculate pay method would run for each of them, because each of them has implemented its own calculate pay method. Okay, is this actually polymorphism? No, polymorphism describes this kind of situation when it's applied to regular inheritance and a child class that's overridden a parent class method. But it's a similar concept where we have a lot of different objects, but when you iterate over a list, the right version of that object's method gets run. So in our example, I think calculate pay would be a great example of that. In the payroll class, you could just have a single list of all your employees, and it doesn't matter what specific type of employee they are. You could still iterate over it and run calculate pay, and for salaried employees, it would calculate their pay that way, and for hourly employees, it would calculate their pay that way. So that's what's good about it. Here's what's bad about it. There's kind of two things that are bad. The first is that there's no inheritance from an interface, because you're not actually inheriting any fields or methods. All you're doing is you're agreeing to implement the methods that are given in the interface, but the interface doesn't actually tell you how those methods are going to be implemented. That's the whole point of the interface. So what's the problem with having no inheritance? One thing it means is that there's going to be potentially a lot of duplicate code in the specific implementations in the children. So for something like calculate pay, we might want that implemented differently in every child. But for other methods in the interface, we might want it implemented the same way in every child. And so in that case, we'd be putting the same code in every single child. And that's a situation where we would probably want to actually just inherit that method from a common parent, because it's bad to repeat yourself. So that's interfaces. So what if we implemented the same system using just inheritance and overriding methods? In that case, you would have a parent class called employee, and you'd have your child classes extend the parent class. And then for any methods like calculate pay, where the children are supposed to do something different for those methods, you would just have the child override the parent method. Alright, so let's talk about what's good and bad about this. So this seems to have all the same benefits in our particular example as the interface does. So we can use polymorphism for the calculate pay method, because we've inherited everything that we need from the parent, and then for particular methods that need to work differently, we override them. So it seems like it's just better for our particular example. Is there anything that's wrong with this? There's one thing that's bad about it. We never actually want to create an instance of the parent class. We never want to create an employee, because employee doesn't mean anything. This class exists only to be extended by its children. So a salary employee is a specific kind of employee, an hourly employee is a specific kind of employee, but there's no such thing as a generic employee in our system. You can compare this to other examples. So in intro last year, we did the animal project where we had foxes and rabbits. We noticed that they had a lot of code in common, so there should be a parent class called animal, but we never actually wanted to create an instance of animal, because there's no such thing as an animal that isn't a specific animal. So in that case, the animal class was, I don't use this term in a technical sense, but it's abstract, because it's not a concrete example of an animal. It names the category animal. So in other words, you couldn't make a furniture, because furniture is a general abstract category. You could make a specific kind of furniture, table, chair, but furniture is too general a category to be something that you could make. So that's what's happening here. We have a general object whose whole purpose is to be extended because this general category style object captures a lot of what's common to all the children. And that's why we created it in the first place. It's so that we can put all of the code that's shared up in there. But the problem is it's not enough. It's not enough detail to be an object on its own. However, if we just make it a regular old class, we would be allowed to create an employee object, and we don't want a system that lets us do that. So that's the purpose of an abstract class. If you mark this class as abstract, you can keep this whole system, you can keep the inheritance and everything else, only it will prevent you from actually creating an instance of the parent class. There's one more feature of abstract classes, which is very similar to interfaces. In an interface, if we know that a particular method needs to be implemented differently by the different children, we would put it in the interface, and we'd only supply the method's signature, and the body would be supplied by the children, because that's the whole point of an interface. For our employee objects, we sort of have a mixed situation. There's some methods, like getID, for example, where the getID method is probably the same for all the children. So we would just want to inherit it. We wouldn't want to force each child to provide its own implementation, because those would all be the same anyway, and we'd have a lot of duplicated code. But for other methods, like calculate_pay, that's one where the implementations need to be different in the children. So it wouldn't make sense to supply code up here in the abstract parent. So what an abstract class lets you do is you can have regular old methods in the parent where you give it a method body and everything gets inherited just the way that you expect from here. But an abstract class also lets you provide what's called an abstract method, where you just give it the method signature ending in a semicolon, and there's no body, just like in an interface. And just like an interface, Java will enforce that any child that extends the employee abstract class has to provide an implementation for that abstract method. So, in other words, it looks something like this. Couple things to notice here. So first, I've marked my class as abstract up here right before the class designator. It still has a constructor, and that might strike you as strange because I told you that you're not allowed to create instances of employee. So if you're not allowed to create instances, why do we have a constructor? Let's come back to that. Here's an example of a method that's similar to the way that you specify one in an interface, but here I've marked the method as abstract. So again, just like an interface, there's no method body, but what this means is that any child class that extends employee is going to have to provide an implementation for calculate_pay. So this is a way of saying that my children have to have a calculate_pay, but I'm not going to tell them how they have to do it. It's up to them. Meanwhile, you can still provide bodies for other methods, and the children inherit these fields and inherit those methods just like regular old inheritance. So it's sort of like the best of both worlds. You get to inherit code that would be the same, but you can force your children to implement methods that would be different. Here you can see the abstract class on the right, and on the left I've got hourly employee, which is extending my abstract class. First I want to point out that we have this override annotation, just like in the case of overriding an inherited method. But in this case what we're implementing is calculated pay, which is the abstract method from the parent. So this would let us provide the implementation. Okay, let's return to this issue of the constructor. So as you know, running super runs the parent constructor. So here I'm running my abstract parent constructor. So why does an abstract class have a constructor? Well, if you remember, ID and name, these are private instance variables, which means that the children don't have access to them directly. I can't say this.id equals ID, because you see here when I hover over it, it says the field employee.ied is not visible. It's not visible because it's private. So the only way I have of accessing these is by either setting them using a constructor or by getters and setters. And if you wanted to, you could use getters and setters if they existed. I could say set name name, and if set name were a method in the parent, that would work fine. But that's a reason why you might want to have a constructor in the parent, so that you could set the instance variables in your constructor. Okay, I just want to make something really clear before we stop. If I were here in some client class, I can run the new hourly employee constructor, and that seems to be working fine. But if I try and run the constructor here of my abstract class, you can see a compile time error. And it says cannot instantiate the type employee, which just means I cannot create an instance of employee because employee is abstract. So what I've been saying all along. Okay, I think that's all you need to know. Good luck. A common pattern that we see a lot is in a lot of kind of production systems, you'll see an interface for a particular kind of object. So for example, a list. Sorry, that was Nadia. So the system might provide an interface for a particular kind of object like a list. Then it would provide a default implementation of the list, which would be an abstract class. And so what that would do is it would implement all of the methods in list that are probably going to be the same for any specific type of list, but it would leave some of the methods from the interface abstract. And so that would mean then you can have a whole bunch of child classes that all extend the abstract class, so they inherit most of the code, and it leaves just one or two methods that are abstract for them to implement. So you could have a sorted list or an array list or a vector, and those are all different kinds of lists that extend the default list. So if we look at the Java API, you can actually see this happening. This is the Java ArrayList class, and down here you see public class ArrayList. It extends an abstract list class, but it also implements a list interface, both of these. So you can open up each one and take a look. So here in abstract class, you can read here about what methods you'd have to override, what abstract methods a child would have to implement, and which ones get inherited. And then over here in the list class, the list interface, you can see all of the different methods that any class that wants to be a list would have to provide implementations for. Okay, so anyway, I just wanted to show you sort of how these things appear in the wild. In the second semester, when we make our crazy adventure game, you're going to need to use all of these ideas together. Okay, I hope this was helpful.